You are welcome to my YouTube channel, Science Joseph. This is your teacher again. I've brought for you another lesson of how to write the chemical formulae of compounds. The chemical formulae is a shorthand of representing a compound using symbols of elements and radicals. Before you dive into a discussion of how do you write chemical formulae, I request that you subscribe this, you hit the subscribe button and also like the video. Now, a chemical formula of a compound is written basically using the valences strictly for elements and the radicals present in that compound. Now, in another video, I've made for you a valence chart having the valences of common elements and common radicals. So, please subscribe this YouTube channel, and also you will be receiving notifications for similar videos on the same. Now, in this video, I've just placed a few valences for some common elements and some common radicals to help us understand how to come up with the correct chemical formula. Let's dive into some of the valences. We have valences of some elements. I have some elements with the valence of 1. I have hydrogen, sodium, potassium. Those have the valence of 1. There are many more, but these are for only learning purposes in this video. You'll visit the valence chart I've provided for you in another video. So, magnesium and calcium have a valence of 2 each. Aluminium has a valence of 3. Silicon has a valence of 4. Some elements have more than one valence, such as lead has a valence of 2 and 4. Copper has a valence of 1 and 2. There are many more other elements having more than one valence, but for the interest of this video, we have provided a few. Now we will have also the valences of radicals. I have some radicals with the valence of 1, some radicals with the valence of 2, some radicals with the valence of 3. So I've placed a few examples here. Let's dive into that. Hydroxide OH, I've denied putting charges on top of either elements or radicals for the interest of beginners who are learning to write chemical formulae. Chloride has a valence of 1, hydrogen carbonate, nitrate, they all have a valence of 1. We have the sulfate and the carbonate, those have a valence of 2, have a phosphate with a valence of 3. So, there are many other elements and radicals, but I'll place a few. Let's dive into some steps. How do you write a chemical formula of a compound? The first very step is that write the symbols of radicals and elements. So you must write the symbol of the element and the radical present in the compound. Number 2, place the valences on the top right. So you indicate the valences. The next step, extend the valences. Then, step 4 is like a rule that wherever you are seeing two valences sharing a common factor, you divide through by a common factor to reduce the valence. Let's dive into some examples. Write the chemical formula of each compound below here. The first compound is potassium nitrate. We say the first step, write symbols of elements and radicals. We have an element called potassium with the symbol N. The valence radical is the oxide with the symbol O. Now, some students are always getting confused. A radical sharing a similar symbol with an element such as oxygen is O, the atom of oxygen is O, the oxide radical is also O. What you should understand that radicals normally have charges, they are charged ions, but elements are not charged. For the interest of this video, we have not put charges. Oxide O remains as a similar symbol with the atom of element oxygen, but here it has a charge, but for the interest of the video, we don't put charges to easily learn. Now, potassium has a valence of 1, oxide has a valence of 2, so we exchange. The 2 comes below here, then 1 comes here. So the actual formula becomes K2O. These 2 must be slightly below a line where we have put a baseline for those symbols there. So the 2 must be around there. So the actual formula is K2O. Let's dive into another example. Lead oxide. When you see a 4 in the brackets, it means this element has more than one valence, so they have specified for you to use this valence. Where an element has one valence, they don't indicate it in brackets. Solid has a valence of 4 in this question. Solid is PV with a valence of 4. Oxide is O with a valence of 2, so we exchange right away. But before we exchange, they share a common factor, so we divide through by 2. So exchange right away there. We shall end up with the actual formula being PV equal to. So the actual chemical formula of lead oxide is PV equal to, because we have ended up with that. Let's dive into the third example. We are looking at magnesium nitrate. Magnesium has a symbol Mg with a valence of 2. Nitrate has a symbol NO3 with a valence of 1. So we exchange right away valences, but we realize that nitrate has 2 different elements, nitrogen and oxygen, so we put the 2 in brackets since we are giving it one to covalence. So we put this in brackets. Always do that whenever you have more than one atom present in the symbol of the radical. Let's dive into the fourth example. Calcium hydrogen carbonate. Calcium has symbol Ca. Valence 2. Hydrogen carbonate is 1,1 with the symbol of formula of HCO3 that has a valence of 1. So we exchange valences. This will go below hydrogen carbonate. So we receive the final formula CaHCO3 with the 2 there. That's the formula of calcium hydrogen carbonate. Let's dive into the last example, hydrogen peroxide. Hydrogen has a symbol H, peroxide has a symbol O2. The valence of hydrogen is 1, the valence of peroxide is 2. So right now we exchange valence at that point. So we receive H2, or we don't divide through by 2 because this other 2 is not a valence. Now that's how we come up with the chemical formula. Watch other videos for balancing equation. Thank you. See you in the next video. Remember to subscribe, like the video. Bye.